For decades, cosmologists have generally agreed on how the universe dies. It expands outward, stars slowly burn through their fuel, and everything drifts apart into a cold, dark void known as the heat death. But imagine the alarms at our most advanced observatories suddenly ringing out with an impossible reading. The outward stretching of space has abruptly halted. This is a scenario gaining traction in modern astrophysics. Recent data from large-scale galaxy surveys suggests our standard timeline might be wrong, pointing instead toward a sudden reversal of cosmic expansion. If this new cosmological model holds up, our universe won't end in ice, it will end in fire, and the countdown to a catastrophic collapse has already begun. To understand how we get there, we have to rewind to the 1920s, when Edwin Hubble observed that light from distant galaxies was stretched to longer, redder wavelengths. This redshift proved that galaxies were moving away from us, meaning space itself was expanding. Albert Einstein introduced a mathematical factor called the cosmological constant to represent a kind of anti-gravity force pushing space apart. For a long time, physicists assumed this outward push was a fixed, unchanging rule of nature. That assumption is now under intense scrutiny. Observations from the Dark Energy Spectroscopic Instrument, located in the Arizona desert, indicate that dark energy, the mysterious force driving our cosmic expansion, might be losing its strength over time. This diagram illustrates the shifting balance of power. If dark energy is driven by ultralight particles called axions, its outward push will eventually weaken, allowing the steady, inward pull of gravity to finally take over. Once dark energy fails, the cosmic rubber band reaches its absolute stretching limit. Gravity asserts total control, dragging the entire universe back in on itself. On day 0 of the collapse, cosmological redshift completely stops. The photons traveling across the vacuum of space no longer stretch or lose energy because the fabric of space is no longer expanding. Then, the physics shift into reverse. As distant galaxies change direction and accelerate toward us, their light waves are severely compressed. We would observe a universal blue shift, with incoming light packing higher and higher frequencies. This shrinking volume triggers a threshold known as the Jeans instability. With all the mass in the cosmos being forced into a tighter space, the ambient density skyrockets until interstellar gas clouds can no longer resist their own weight. The immediate result is a runaway gravitational collapse. Across the cosmic web, gas clouds violently fragment, triggering explosive bursts of massive, bright blue star formation everywhere at once. This sudden boom in stellar birth is a symptom of a dying cosmos. Gravity is forcing all matter onto a high-speed collision course. Fast forward a few billion years into the contraction phase, and the night sky is unrecognizable. Entire galactic clusters, including our own local group, are crushed together into chaotic, swirling megagalaxies. We can see the true thermodynamic danger in this chart, which tracks the cosmic microwave background. This ancient ambient radiation is compressed by the shrinking universe, causing its heat to spike exponentially. The previously cold black voids of space are saturated with highly energetic radiation, turning the entire sky into a blinding white-hot plasma. The ambient temperature of space soon eclipses the core temperatures of the stars. Unable to radiate their internal heat, the stellar surfaces physically dissolve and boil away into the glowing void. The cosmos becomes an inescapable oven. Every biological organism, planet, and star is completely incinerated long before the universe reaches its final physical limit. In the late stages of the collapse, the only intact structures left are supermassive black holes. As space shrinks to a fraction of its original size, these gravitational titans are forced into the same microscopic neighborhood. They rapidly fuse together, consuming the remaining plasma and dragging space-time into a single, infinitely dense singularity. This is the Big Crunch. But theoretical physicists working on cyclical cosmology models suspect this singularity is not a grave. It might be an engine. Extreme spatial compression causes higher dimensional fields to collide. The immense kinetic energy of that collision is instantly converted into a brand new Big Bang. The catastrophic destruction of everything we know could simply be the necessary spark required to birth a brand new universe. Our current universe is roughly 13.8 billion years old. If the evolving dark energy model is indeed correct, we have about 20 billion years left before the final crunch. Our sun will burn out, and Earth will be rendered uninhabitable billions of years before the cosmic clock runs out. We won't be here to witness the end. Yet, uncovering this timeline offers deep poetic resonance. Out of all the chaos and void, we are the universe momentarily waking up, looking at the stars, and finally calculating its own lifespan.